This is a higher chemistry tutorial on rates of reaction. Before starting going through a question, I'm going to go over what the SQA has written on their website, on their curriculum for the higher rate of reactions. So, rate of reactions can be followed by measuring changes in the concentration, mass, and volume of reactants or products. So that means to calculate the rate of reaction, you need to either measure the concentration, mass, or volume of either the product being made or the reactant being used up. Average rate of reaction, or rate in a stage of reaction, can be calculated from the initial and final quantities and the time interval. So, rate is always given as a positive value. Therefore, if you're calculating the rate, you need to use the largest quantity minus the smaller quantity within that given time interval over the time interval. So let's get on with the question. Question is from 2011, section B, question 1. Chloromethane can be produced by reacting methanol solution with dilute hydrochloric acid using a solution of zinc chloride as a catalyst. The reaction is shown there, and you can see that because it's all aqueous and a liquid, this is a homogeneous catalyst. So we're going to now go over to the next section of question B, which relates to rate. It says, the graph shows how the concentration of hydrochloric acid changed over a period of time when the reaction was carried out at 20 degrees C. The first question asks, calculate the rate in moles per litre to the minute to the minus 1 for the first 400 minutes. So the first thing to do is to jot down the time interval, so between here and here. So now what we need to do is we need to work out the concentrations at the time intervals. So go up, go across. So that's the final, and that's the initial. So, initial equals 1.80 moles to minus 1, and then final equals 1.20 moles to minus 1. So, to calculate the rate, we use the equation that I discussed on the previous page. Rate equals initial 1.80 minus final 1.20 moles to minus 1 divided by the time interval. So 400 final minus initial naught. Therefore, 0.6 divided by 400 equals 0.0015. And this is because there's minutes in the bottom, this is minutes, we have, it is made to the minus 1, so the units are moles to the minus 1, minutes minus 1. So that's the answer for the first part. And the second question, the second part asks, on the graph above, sketch the curve to show how the concentration of hydrochloric acid would change over time if the reaction was repeated at 30 degrees C. So you can see here, it's 30, one to 30 degrees, and that one is 20 degrees. So increasing the temperature increases the kinetic energy of each molecule, and therefore more collisions are successful. So therefore the concentration of the acid will decrease faster. So what they're looking for is a slope that starts at the same point, starts at the same point up here, as the concentration can be said, but has a steeper gradient and curves similar. So something I've looked through a lot of past papers on rate, and the majority have a rate calculation question in section A and have a question on collision theory in section B. The section B question is often linked to and requires knowledge from your PPA. These questions seem to make you think on your feet, and I've noticed they change year on year. Therefore, it's a good idea to get as much practice as possible. They're all in the document in the description, so you can try them as much as you want. So I'm going to go through a 2008 section A part question, just to show you what they usually like. The following results were obtained in the reaction between marble chips and dilute hydrochloric acid. What is the average rate of production of carbon dioxide in centimeters cubed, minutes to the -1, between 2 and 8 minutes? So the first thing to do is to write the rate equation, which is rate equal to largest quantity minus smallest quantity divided by time interval. So the largest quantity is 82, so 82 minus smaller 52 divided by the time interval, which is 8 minus 2, so we have 30 divided by 6, so the answer is 5 centimeters cubed in -1. So